Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, today our group will present about the third wave, which is photonics. Okay, we have 5 group members. First is Muhammad Aiman Hakim bin Cik Hamid, which is me. Second, Muhammad Almi bin Abdul Aziz. Third, Muhammad Ahmad Rashidi bin Razwam. Fourth, Muhammad Akmal Azhan bin Muhammad Fauzi. Fifth, Nurul Syafiqah binti Syaharuddin. Okay, now we will go to our content. Okay, our first content is introduction, next background history, then application, and lastly future trends. Okay, now we will go first to our introduction that will be presented by Nurul Syafiqah.
Introduction. The word photonics is a combination of the word photon and electronics. Photonics means the physical science of light wave. It is the technology of generation, detection, as well as manipulation via transmission, signal processing or amplification, and data transmission, such as optical fibers and in optoelectronics. It is used in laser printing or digital photography and also used in connection between computers and telephone lines. Photonics is made up of many different technologies, including optical fibers, lasers, detectors, quantum electronics, and so on. Photonics is related to optomechanics, electro-optics, quantum electronics, and quantum optics. Now we move on to the background history that will be presented by Amar.
Okay, background history of photonics. The word photonics is derived from Greek word phos, meaning light. It appeared in the late 1960s to describe a research field whose goal was to use light to perform functions that traditionally fell within the typical domain of electronics, such as telecommunication, information processing. In 1917, Corning Glassworks demonstrated highly transparent fibers, and Bell Laboratories demonstrated semiconductor lasers that could operate at room temperature. Other development followed, including the optical fibers for transmitting information and the erbium doped fiber amplifier.
I will continue to background history of photonics. The term photonics came into common use in the 1980s as fiber optic data transmission was adopted by telecommunications network operators. Its use was confirmed when the IEEE Lasers and Electro-Optics Society established an archival journal named Photonics Technology Letters at the end of the 1990s. During the period leading up to the dot-com crash circa 2001, photonics as a field focused largely on telecommunications. Various non-telecom photonics applications exhibit strong growth, particularly since the dot-com crash, partly because many companies have been looking for new application areas. Further growth of photonics is likely if current silicon photonics developments are successful. I will pass to next presenter, Muhammad Almi.
Application of photonic. Application of photonic abound use a more time and many benefit certain field. One of benefit of use photonic is being immune from electromagnetic interference EMI. The following is used photonic is a peculiar field. First, medical application. Laser sugar for ear sign correction and tattoo removal. Second, manufacturing process in industry. Example, involve the use of the laser welding, cutting and drilling. Third, space exploration and execution. Example including estimation and telecoms. 4. Meteorology, range finding, frequency and time measurement. 5. Telecommunication. Example, obligation down converter to microwave. 6. Building and construction. Example, smart construction, laser range, feeding and laser lasering. 7. Military operation. Example, command and control, IR sensor, navigation, mine laying, hard and service. 8. Photonic computing. Printed circuit bonds and quantum computing. Next, I pass to Ahmad Azhar to explain future trend.
Thank you to Almi. I will proceed to future trend of photonics. First and foremost, photonics enable point of care diagnostic and genomic screening will be supported with integrated photonic and new deep tissue scanning technique. Non-mechanical beam steering and single photon techniques will advance LiDAR system for autonomous vehicles. Advance in photonic sensing, including improvement in sub-nanometer optical imaging and chip-level ultraviolet subsystem will also benefit a wide range of applications. The next is lasers are essential to the manufacturing of everything from cars to medical implants, making materials processing such as cutting, joining, and marking. They are most valuable market. The trend toward marking technology more smart is now driving laser innovations, balancing dedicated mass production against flexible manufacturing. The last one is there is remain substantial potential for very high efficiency laser approaching to 95% with this, the associated economic and environmental benefit. We also expect new innovation in extreme high power and high energy laser, including those emitting ultra short pulse for ultra fine submicron material processing and lithography. High speed and accuracy glass and ceramic and processing of difficult material, example Cooper in electric vehicle, to support new fundamental science and defense application. That's all from our group. Thank you.
Lebih 2 minit ke?
Lebih berapa minit?
Tu. Tak tahu.
Start.
Sampai record.